You know, our medical systems are absolutely incredible at capturing a single moment in time, a snapshot of our health. But what happens when the real story isn't in that snapshot, but in the slow, almost invisible changes that happen between them? Today, we're going to explore how medicine is learning to remember.
This quote, wow, it just nails the problem, doesn't it? For diseases that creep up on you, accumulating damage over months and years, our current approach often misses the entire plot. It sees the before and the after, but the crucial story of how we got from one point to the other, it's just lost. So to really get why this matters so much, we have to start with the human side of things. All those moments that never ever make it into a medical file.
This right here, this is where the real story of a chronic illness actually lives. It's when a family member notices the stairs are getting just a little bit harder, or a word is right on the tip of your tongue but you can't quite grab it. It's that subtle gut feeling that something is different, even when the official report comes back saying everything looks stable.
And here's the kicker. For conditions like multiple sclerosis or early Alzheimer's, the disease doesn't show up in some big, dramatic leap. It's more like a slow burn, a quiet accumulation of tiny, tiny changes. And the scary part is, by the time those changes are big enough to be obvious on a scan, a lot of irreversible damage has often already been done.
Okay, so let's shift gears and look at the system itself and see how this memory gap is literally built right into our medical infrastructure.
We basically practice what you could call snapshot medicine. Each MRI is treated like a totally separate, disconnected event. The data is episodic, it's fragmented. The system has no real memory, which means its intelligence can't build on itself over time. This visual just lays it out so perfectly. On the left, you see MRI today. It's all these disconnected scans with no memory. But then, look to the right, at MRI as infrastructure. It's completely different. Here, all those scans are woven together into a single, continuous timeline. This creates a living record that lets us analyze change over time. It is a fundamental shift from isolated pictures to a coherent story.
The way we do it now relies on a highly skilled human literally eyeballing two incredibly complex images, side by side, trying to spot subtle differences. And don't get me wrong, it's an amazing skill, but it's also really time-consuming and naturally inconsistent. Different scanners, different doctors, they can all lead to different interpretations. So, the big question is, how do we fix this? Well, the solution comes from a concept that'll be very familiar to anyone who works in software. This is the breakthrough idea. Instead of just storing a new image as just another file, we treat each scan as a new version of the patient's health record. The system is built from the ground up to understand the history, the context, and, most importantly, the changes between each version.
And here's exactly how it works. Step 1 is to align. Each new scan gets computationally lined up with all the previous ones, creating a common reference point. Step 2, compare. The system then automatically calculates the difference, the delta. And finally, step 3, record. That change gets recorded not as some subjective note, but as structured, measurable data.
And this is the fundamental shift. It moves us away from a static analysis to a dynamic one, because the most important signal in a chronic disease isn't the state of things today. It's the trajectory of change over time. It's not where you are, it's where you're headed. Okay, so this all sounds pretty great in theory, but what does it actually mean for a patient? Let's look at a real-world scenario.
So here you can really see the disconnect. For 3 straight years, the official reports say stable, unchanged, but the patient knows something is wrong. They feel it. Their own body is keeping a more accurate record than the medical system is.
But a system that has a memory, it sees something else entirely. It detects a pattern, a tiny but consistent trend of tissue loss that is statistically undeniable, even if you can't see it with the naked eye. This is the signal that was hiding in the noise. And this is the chance to act before disability becomes obvious. This chart just sums up the whole paradigm shift. We move from reactive care, where we're always playing catch-up with the disease, to proactive care, where we can intervene based on the earliest trends. It's the difference between waiting for the dominoes to fall and maybe stopping the chain reaction before it even starts. The system that waits versus the system that remembers.
So let's zoom out and see how this builds into a much, much bigger idea. This isn't just about one disease. This is about laying a whole new foundation for medicine itself.
I mean, while multiple sclerosis might be the proving ground, this exact same infrastructure can be used to track the slow progression of Alzheimer's, the subtle growth of a tumor, or even how effective a new drug is. Really, any condition where change over time is the key signal can benefit from a system that's built on memory. And really, this is the ultimate takeaway. For years, we've thought the answer was just to build better, smarter AI models, but the real revolution isn't just a smarter algorithm. It's providing that algorithm with better data. Data that's continuous, that's versioned, and that's full of context. When medicine finally gains a memory, intelligence can finally begin to compound.
So I'll just leave you with this question. At their core, progressive diseases are thieves of time. So to fight back effectively, we have to use systems that understand time, that respect it, and that remember every single second. And building that memory might just be one of the most important things we can do in medicine today.